Oops. Don't want to be caught in a sticky situation without this bad boy. Blue 42. Is that a cardboard cutout of Hillary Clinton?
Nice try, Joe. That's the oldest trick in the book.
No, seriously, look.
What? Not so fast, huh? All right, let me just zip tie your hands. Here we go, Joe.
You're coming with us, buddy. Come
All
on,
right.
into the car.
Yeah, you're going for a little bit of a ride. Don't hit your head on the way in, Josephina. Don't worry, I'll get the girl. Stop waving. All right. All right, princess, let me show you to your chair. All right. We'll be right back. We gotta watch curling.
How am I gonna get out of these zip ties? I need to call the police.
What is your emergency?
Help, I've been kidnapped by two strange men.
Oh, well, do you see anything that can help you escape?
Yeah, there's a saw here. There's a baseball bat. There's a couch next to a book and a room on the ceiling. And an I shot the sheriff.
Wait, go back.
What? The axe?
No, something about a calc textbook.
Yeah, it's open to rhyme and song.
Oh, well, did you pay attention to the speedometer every minute that you were in the car?
Yeah, of course I did. I'm not an idiot.
Oh, well, perfect. Well, if you can determine the area under the curve, you can tell us that distance, and we can determine a search area for you. Can you do that?
Yeah, there's pens, pencils, a calculator, and paper here.
Perfect. Let me know.
Hey officer, you still there? I just finished my work. I've got the left, right, midpoint, and trapezoidal rhyme and sung. I'll take a picture of it and send it to you right now. Oh crap, they're coming. I gotta put this stuff away.
Come on, man. We discussed this. Are you kidding me? We've been over this 1,000 times. You can't even walk straight. How do you expect to torture this kid? We got it. You can't even walk.
I'm not like it if I repeat from you. Oh, here we go. All right, Josephina. Time for some real torture.
No! Please don't hurt me!
Ah, thank God. That screw is driving me crazy. Now, Josephina, do you like 70s music?
Ah!
Oh crap, what was that?
Ah, dude, it's just your car.
Wait a second. I don't think that's where I parked, man.
Oh, crap! It's the cops!
Looks like you fellas didn't drive safely.
I got the feeling that something ain't right. I'm so scared in case I fall off my chair. Clowns to the left of me, jokers to the right. Here I am, stuck in the middle with you. Yes, I'm stuck in the middle with you.
Driving can be fun.
And I'm wondering what it is I should do. It's so hard to keep the smile from my face. Lose control, yeah, I'm all over the place. Clowns to the left of me, jokers to the right.
The purpose of our
Here I am,
lab was to
stuck in
determine
the
an approximation of the distance traveled based on a data set of speed versus time points.
Our method for this experiment was having Riley, the knucklehead who could drive for 15 minutes, and we took the speedometer reading for every minute. We also took the beginning and the ending odometer readings to see how far we traveled according to the car. When we got back, we graphed the speed versus the time, and we took the left and the right Riemann sums, and we also did the midpoint and the trapezoidal sums as well.
For the left-hand Riemann sum, what we did was we graphed all the points, and the blue boxes are the left hand, so it's from here to here. And what we did was the summation of I equals 1 to 15, because there are 15 points, of f of x of I minus 1, because I minus 1 is to the left, times change in x, and change in x is b minus a over n. And we put this all over 60 because there are 60 minutes in an hour, and in this case, our graph is in minutes. Our approximation for the left-hand Riemann sum was 8.516 miles.
For the right-hand Riemann sum, we also had 15 data points, and we also start at 1. But the difference is here that we used f of x instead of f of x minus 1, because Joe wanted the points from 0 to 14, but for the right Riemann sum, we used 1 to 15. So we took the area under every point from 1 to 15 and added them together, then divided by 60, because there's 60 minutes in an hour. And then we found our area under the curve. The approximated distance is about 9.35 miles.
For the midpoint Riemann sum, we use the formula f of x of I minus f of x of I minus 1, all divided by 2, to find the point in between each of the data points that we took that's on the graph. So the blue lines on this graph represent the midpoint points on the curve and the rectangles. So we added up all of those values and divided by 60 because there's 60 minutes in an hour, and our approximation was 9.433 miles.
For the trapezoidal Riemann sum, we use the equation area equals 1/2 times base 1 plus base 2 times the height to find each trapezoid under our data points on the graph. This translates to 1/2 times f of x of I plus f of x of I minus 1, which would be the heights of the trapezoids, times change in x, which is this distance between the times. We added up all these distances, or all these areas, and divided by 60, because there are 60 minutes in 1 hour. Using the trapezoidal Riemann sum, we approximated the distance to be 9.433 miles.
For each graph, the black line is just an approximation for our speed, except for the points. So it's not our actual speed at that time. The reason the trapezoidal and midpoint approximations of the Riemann sums are the same is because if you take a look at the graph, this area here and this area here are roughly the same. In addition, this one and this one are roughly the same, so they essentially cancel each other out, which makes the trapezoidal and midpoint the same.
Because we started at 0 miles per hour and ended at 50 miles per hour, our left-hand and right-hand Riemann sums will not be the same. If we started at 0 and ended at 0, then the left and right would be the same, because when you're taking the left Riemann sum, you use the left hand heights, so you would start at 0 and go to 14. However, when you use the right hand Riemann sum, you start at 1 and go to 15. So the right hand Riemann sum was significantly higher because we used 50 miles an hour as a height as opposed to 0 miles an hour as a height in the left hand Riemann sum.
The odometer may have read that we went 8 miles, but since it only reads to the nearest integer, it could have been anywhere from 8 to 9 miles.
So according to the left hand Riemann sum, our approximate distance was 8.516. According to the right hand Riemann sum, our approximate distance was 9.350. According to the trapezoidal, it was 9.433, and the midpoint was the same. Our actual distance traveled was 8 miles. All of these Riemann sums were overestimates because our speed curve doesn't account for when we stop the car. So as we were driving, we encountered stop signs and traffic lights, and we had to stop the car. But the speed curves are just approximations, so they don't actually account for the speed returning to 0 miles an hour.
Riemann sums? Integration? You mean we could have used integration?
Let's start.
Not so fast, huh?
Oh, that was a bigger failure than her election campaign.
Alright, here we go, princess. Are you your hands off?
Help, help.
Take 5, 3, 2, 1. No.
Shot the sheriff.
911, what is your emergency?
Help, help. I've been kidnapped by 2 older men. One of them is wearing an eye patch.
Yeah, did you say Ryman sums?
Yeah, I said Riemann sums.
Well, what do I say now? Oh, perfect. Well, you can just calculate the area under the curve, and then we can send out a search area with that area. Oh, perfect. Okay, so you can calculate the area under the curve, and then let me know what that is, and then we can send out a certain radius of search area.
Great. Help, help. I've been kidnapped by 2 strange men. There's a baseball bat here. There's a cow.
Joel!
Okay, I just finished my work. I've got the left, right, midpoint, and trapezoidal Riemann sum. So I just finished my work of the left. Okay, I just finished my work. I got the left, right, midpoint, and trapezoidal Riemann sum. I'm sorry. Okay, I just finished. Oh my god. Ah! No!
Oh, crap! Ryan, you messed it up! We gotta go camera.
Is that a ski pole in between your legs, or you're just happy to see me? For the midpoint Riemann sum, Riemann.
For the right Riemann,
For the left hand Riemann, for the left hand and right hand Riemann sum, and Riemann. Riemann sums. Integrals? You mean we could have used these?